Hello and welcome back to PaleoCast. I'm Dave Marshall, this is Dr. Jakob Winter, and we're in the Senckenberg Museum where we have this beautiful specimen. What is it?
Well, this is a dinosaur called Psittacosaurus. It's about 120 million years old, and it's from a locality in northeastern China in a province called Liaoning. It's from a series of deposits, lake deposits, called within a formation called the Yishang Formation. And a lot of different fossils have been found there. Feathered dinosaurs, plant fossils, naked dinosaurs, and a lot of other things as well.
Yeah, we can tell it's naked because we can see its bare skin, right?
Yeah. And the skin is preserved across the whole animal here, which is very, very nice. Furthermore, we have preservation of melanin, which means that we can reconstruct its color patterns. So that's something that we've just done in a recent study. Another thing that I just want to briefly mention is that you have these peculiar bristles here, which has been substance to another paper that we just published in Paleontology.
So, a couple of points there. We've got the melanin and we've got the bristles. First of all, the melanin. How can you tell that it is a pigment?
Well, that's a very good question. There are different ways with which we can study melanin. One thing is that we can do chemical analyses. People have done that from various types of fossils and demonstrated that we can get molecularly intact melanin. The problem with this specimen is that it's covered by varnish. So in order to protect the fossil from handling it and so on, they put a thick layer of varnish on top. That complicates doing any kind of chemical analysis of the specimen. But there's other ways with which we can identify melanin. And one other way is that we can take samples and look for little bodies called melanosomes. And that was one of the first ways with which we were able to demonstrate that feathers and things like that are actually preserved by the presence of the melanin within them. So we're taking samples of the specimen, found little round bodies of melanosomes, which potentially suggests that it might have had a brown color originally, whereas now it looks more black. And then finally, another thing that we can see is that there's color patterns in this animal. We can see there's nice stripes and spots and these kind of reticulating patterns here, which also demonstrate that what we have here are clearly color patterns, things that could not be generated in any other sort of way.
Now, the colour patterns are pretty exciting because animals use colour in a whole heap of different ways. Like, you can use it for camouflage, you can use it for signalling, you can warn people, you can say, hey, look, I'm attractive, I'm wearing a gorgeous burgundy t-shirt with Thrasher magazine on, I'm gorgeous. So can we infer a purpose for this coloration?
Indeed we can. So there's a number of different color patterns in this, and there is probably a number of different functions that they serve. One of the really conspicuous color patterns in the fossil, which is the focus of our paper in Current Biology, is that we see that it's got a much lighter belly here, which is the skin that we see exposed there. And you can see that it becomes darker and darker as we move up onto the back. We can see that also on the tail. So that's a color pattern called counter shading. And counter shading doesn't look like something that is very sort of conspicuous or something that might serve a very important function. But experiments and all kinds of observations have shown that this kind of counter shading works by trying to eliminate the shadows that are cast on your body by sort of making those areas that are usually in shadow lighter, and that actually can make you look more flat, because shadows is actually a way with which we are able to tell shape. And if you don't want to look conspicuous, if you look a little bit more shapeless or like sort of optically flat, that can give you a selective advantage. So that's one of the things that we have been studying in our recent paper, this counter shading. So that's one of the conspicuous patterns that we see here. And I can also maybe explain what we can say about this animal based on this counter shading.
Please do.
So the thing is that because you're trying to eliminate the shadow that is on your body, we can see in living animals that there is a good correlation to the environment that you live in, because depending on the kind of light that hits you, the shadow will look different. So you can imagine if you live in an open habitat like a savanna or like a grassland area, something like that, the light just comes straight down onto you. That means that you will have a very sharp shadow, and the shadow will sit very high on your body. And that means that the counter shading that you need to have in order to sort of counter illuminate this would be also very high on the body, and the transition would be very sharp. But if you live, for example, in a forest, the light has been sort of broken up by the forest canopy, and the light is sort of much more diffuse when it comes down. That means that it comes more in an angle and it's much more sort of irregular. So that means that you have a shadow that is much lower down on your body, and it's also more gradual in its transition. So what we can see in the animal, and we've been able to infer that by making a three-dimensional reconstruction of this fossil and then carefully projecting the color patterns onto the anatomically correct parts of the animal. Then we can see that the transition is very far down on the body, and by taking another cast of the model that we built and then photographing it in different lighting environments, we can see how the shadow is cast, and then we can see that the best matching shadow is one that is generated when we have this kind of like diffusely lit environment. So to make a long story short, we think that this dinosaur lived in a forest.
Surely that's a very high-tech solution to work out what environment it lived in. Isn't it preserved in that environment? Can't we look at the rocks that it's preserved in and say like, hey, here's a bit of a tree. It probably lived in a forest.
Well, you can do that, but the thing is that the deposit that it's preserved in was a lake, and obviously this dinosaur did not live in the lake. It got transported into the lake. And in the same deposit we do find fossilized tree trunks, we find plant material, we find evidence of coniferous plants that form the trees around. But the thing is that you'd never know, like this is so unique when you find a fossil like this. So you don't know whether these things might have lived further away from the lake, and you don't know whether like these tree trunks and plant material has been transported from much further away. So there are some complications with that. But of course the fact that we find tree trunks and we find plant material in great abundance in the same deposits does suggest that indeed there was a lot of forest and plant vegetation around this lake. And the fact that these psittacosaurs are not super rare in these deposits probably suggests that they probably didn't live that far away from the lakes either. But you can sort of say that they provide you sort of with an independent line of evidence that support alternative evidence. And in science, it's great if you have different lines of evidence to support the same conclusion.
Okay, and the quills on the tail, what might have they have been used for? Because it's a naked dinosaur. It's not covered in feathers, but it has got just this really obvious little cluster of them. What? Tell us.
Well, the thing is that we've seen that there are like those kind of like primitive feather-like structures in many dinosaurs. And when we find it, for example, in theropod dinosaurs, they're usually covered all over the body, which suggests that perhaps it was used for primarily insulation. And when we see they become more elaborate, and then maybe they've been used for display. But this dinosaur clearly did not use its bristle-like structures for insulation, because why would you only want to heat the top side of your tail? So we need to think about what alternatives there are. Another one could be perhaps be like sort of defense, because if you think about like, for example, the porcupine, they have like really big sort of spines that are coming off the backside of their body. But you can see these bristles here are much more droopy. They look like they must have been quite soft and not been able to provide much defense in that in that sort of way. So therefore, we are actually speculating that perhaps they could have been used for advertisement in some way or another. One way could be that perhaps they sort of enhance the relief of the animal. They sort of make the animal bigger, and that could be one way with which you could have been giving it some kind of like advantage and serve for display. Another one that I've sort of been speculating about is whether they could sort of rattle them. If they shook their tail, then they would have made sort of like a rattling sound.
Do porcupines do that?
Actually, I don't know. That's a good question, actually.
I'm sure some animals.
Yep. Some animals must do it. Yeah. Please write in and tell me, because I don't know much about living animals.
Right. I'm just going to break the fourth wall and check to see if we've got enough space on the camera. Yes, we do. Yes, we do.
Excellent.
We got 10 minutes.
Brilliant.
Sorry for that interlude. Right. What other things can we tell from the melanin? Because it's not just the colour patterns that are preserved in this.
Yeah. Well, so one of the things that we can see in living animals is that melanin can also be used for other types of reasons. So one is that it can provide certain tissues like keratin, like for example our nails, with more resistance to abrasion. So by putting melanin into these hard structures, it makes them more abrasion resistant. And we can see that there are certain parts of the body where you have more pigmentation relative to other parts that are just adjacent to it. For example, the angles down here, there are some big pigmented scales there. And probably when it's set down, it would be resting on those angles. So therefore, they would be sort of rubbing against the soil. And so having more pigment in those would make them sort of more resistant to rubbing. Another part of the body that would get in contact with the soil when they were sitting down would be the sort of the tip of the pubic bone here. And what you can see is that the integument around the pubic bone, there are some very large pigmented scales also. We actually think that there might have been like sort of a little sort of thickened pillow of tissue with those scales on the pubic bone there. So we can actually see that there were some parts of the body that it used to sit on where there are also like sort of more heavy pigmentation. Now the last thing that melanin can be used for is to protect tissues against microbial infections. So what we can see is that certain internal organs are pigmented, like for example our liver. There's a lot of melanin inside our liver. And we can actually see there's lots of black material which we can infer is from inside the body here. So that's probably preservation of the liver.
Why can't it be the coloration coming through from the other side? Because the fossil's splat, completely flat.
Yeah, indeed.
So yeah, you've got the other side. So couldn't that just be color coming through?
Indeed. Like we see a sort of a conflation of the skin from two different surfaces on the hind leg here. And we were speculating, well, that could be the case also for this dark material that you see here. But the thing is, you can see that the black material is actually lying on top of the vertebrae here. And that means that it must be lying on top of the spines, and we're like looking at the animal from below. So that shows that it's not the skin from underneath that is sort of peeping through, because then it must have been sort of like going underneath the spine. So therefore we can actually disentangle it and show that it's not the skin from the back, and it's not the skin from the belly. So therefore it's something in between, and that must be somewhere inside the abdomen.
Sure.
One last thing, we have the cloaca preserved, which is pretty exciting. I don't think there's many cloacas preserved in the fossil record.
So a cloaca is in archosaurs, isn't it? So crocodiles and alligators and also birds.
Yeah.
And it's a joint.
Joint opening for everything that you need to get rid of.
Okay.
And monotremes, sort of very primitive mammals, they also have cloacas.
Okay.
But we have a cloaca in this animal preserved. I don't know if there is many dinosaurs preserved with the cloaca intact. I don't know. Maybe you
I'm
can
not
write
a
in.
dinosaur guy, so
Write in and tell us if you
show us your cloacas.
Please do.
Hashtag my cloaca.
But you have a very nice cloaca in this fossil, and it's pigmented. And we can perhaps say that in humans, the genitals and the anus is also pigmented for that reason, because it protects against infection. You don't need to demonstrate it, Dave. But it's true, you can look in your mirror at home. That's pretty interesting. So therefore, this dinosaur also had a pigmented cloaca for that reason, to protect against infections in this body opening that could potentially get exposed to a lot of bacteria and things like that. And we can actually see a little bit of the anatomy of the cloaca as well, which I think is pretty interesting. You can kind of like see that there are like sort of two sort of lobes that are sort of pointing in this direction, and then probably the opening sort of came in this way here. So that's pretty interesting. I don't think anyone has been describing the cloaca in more detail, so maybe I should do that at some stage.
Yeah, it's a really beautiful fossil, and I guess like there's nothing quite like this one.
No. There are some other dinosaurs from China, that also pterosaurines, that are preserved with skin. But unfortunately, some of those, you don't have the skin fully intact across the body, or they're exposed at different angles. So you see them from the back, and you kind of see all those nice patterns from the lower surface. So there are other specimens, but I don't think any of them has been prepared to the level that this specimen is, and they're not as complete. So this is really a unique specimen, but I think there will be other specimens coming out of China that going to be as spectacular as this one in the years to come.
Right, well thank you very much for showing it to us. I hope you've all enjoyed taking a look at this remarkable specimen, and let us know what you think of these colour patterns. Can you see anything, or can you think of any reasons it might have these colour patterns? What might this dinosaur have been doing in real life? So thanks very much for watching, and we'll see you again next time.